Hello everyone. My apologies for not being here today. I'm actually running another training at this moment, so it kind of makes it difficult to be in two places at once. What I'd like to do is actually go over some different strategies that you can use for teaching the scientific method during quarter one for next year. So without further ado, let's begin. So, okay, let's take a look at the benchmarks for Unit 1 on the scientific method for quarter one for next year. And let's focus specifically on the first benchmark. It says on here, raise questions about the natural world, investigate them individually and in teams through free exploration and systematic investigations, and generate appropriate explanations based on those explorations. So you really want to get your students doing science by performing various labs. So for example, for making predictions, you can have your students work on the how many water drops fit into the top of a penny lab. This is actually one that's very simple to do. You don't need a whole lot of different materials for it. Really all you need is a cup of water, a penny, an eyedropper, and some paper towels. But again, for making predictions, this is a great one because what you do is you try to see how many water drops will fit on the top of a penny. Students should actually write down what their hypothesis or what their prediction is before they actually do the experiment, and then they go through and do it. Now keep in mind that if a hypothesis is not shown to be supported with data, that's okay. Students will actually may get it right or they may get it wrong at first, and that's fine. That's how science works. So what I did is I actually included a copy of this lab, and then all you have to do is just click on this link right here and you can get a copy of it. There's a couple different variations you can do with it, but it's a nice fun one to do. Here's another good scientific inquiry activity on building a raft, and this one's on page 10 of the textbook. And again, one important thing to note here is that you want to make sure that you're using those vocabulary words often. Things like variables and predicting and drawing conclusions, experiment. You really want to use all these words. The more and have your students actually use those words. The more times the students are exposed to the vocabulary words, the more likely they are to remember them as well. Another thing you can do with your students is have them practice making inferences. The textbook defines an inference as a way to draw a conclusion about something. And that's true, but it's a little more than that. It's more like a logical explanation for an observation that is drawn from previous knowledge. So we tend to practice observation skills with our students by having them use their sense of sight. Here's one where you can have them practice their listening observation skills. So to emphasize that observations can be made by using any of the senses, ask students to listen to soundtracks from movies. From their observations, have the students infer what happened at the point of the movie. So for example, if the music was upbeat, then students can infer that it was played during a happy scene. So what I did is I took one of my favorite film composers, John Williams, and I just kind of did a quick Google search, actually a YouTube search of some of the different soundtracks from different movies. And what you would want to do is play these soundtracks just for a minute or two and have your students just listen. Don't play the video that goes with it. In fact, shut your monitor off. Just have them listen to this instead. And then have them infer what is the feeling of the song, what's going on at the movie at this time. The third one down is actually one of my favorite ones, and it's that Jaws theme. You remember that old dum right? So that's a good one for them to try to infer, because some of these they'll recognize, but some of these they may not. And again, this is a great way to incorporate the arts into science, and your kids really will enjoy doing this. Okay, so now let's move on to fourth grade, and again, let's look at the benchmarks covered for Unit 1. And let's specifically look at the last two benchmarks here. And it says, keep records that describe observations made, carefully distinguishing actual observations from ideas and inferences about the observations, and then recognize and explain that scientists base their explanations on evidence. We really want to give our students an opportunity to be exposed to the scientific method by being part of hands-on explorations. So this is an activity that's on page 3 of the textbook, and it's written very well. The only issue that I had with it is that I had a hard time following the instructions for making these paper helicopters. So I found a really good video on YouTube, and then it actually walks you through how to make the different paper helicopters. And I also found a template from a lab that your students can use if you would prefer to do that. And I've included both of those in this slide right here. But part B is the really cool part, because this is where students can actually come up with different variables to test. So they can try adding more weight to the paper helicopters. They can try using different kinds of paper. By the way, a material that works really well for making these paper helicopters is note cards, index cards, are really good for making these. So this is where you want to have students come up with a hypothesis, a procedure, results, conclusion, really practicing those steps in the scientific method. Here's another great inquiry activity that you and your students can work on, and it comes from the Exploratorium in San Francisco, California. This is a great resource for hands-on activities, especially at the elementary science level. The Exploratorium, for you guys that don't know, it's a huge hands-on museum, and their site has a ton of little activities that you can do with your students. So I included 2 on here for making bridges. One of them is for making a bridge out of an index card, and then you try to put pennies on there to try to see how much weight it can hold. And then the other one is a little bit more in-depth, but it's really good, and it's making newspaper bridges and trying out different styles and everything. So it's kind of some cool activities. Okay, and again, the Exploratorium is a really good site for you. All right, so now we're moving on to the 5th grade benchmarks, and there's a lot of them. And they're all important, but the one that I really want to focus on is the last one on this page here. And it says, identify a control group and explain its importance in an experiment. And of course, there's another set of benchmarks here that you want to make sure that you're familiar with. So your textbook mentions Francesco Redi, and Francesco Redi does a classic example of an experiment that really follows the steps of the scientific method. One of the things that would be good to do, and I'm going to show you the image from your textbook here in just a minute, but one of the things that would be interesting to do is, as you are describing this experiment, have your students kind of write down the different parts of the scientific method. Okay? So to kind of give you a little bit of background knowledge, what Francesco Redi was trying to disprove is the notion known back then of spontaneous generation. So one of the things I've always liked to do with my students is have them break down a word if they don't understand it. So at least try to get something out of it. So if you look at the word spontaneous, or the 2 words spontaneous generation, it literally translates to all of a sudden to make, or in this case, to make life out of nowhere. Okay, so here's what Francesco Redi did. So Francesco Redi set out to disprove this concept of spontaneous generation, which again said that living things can come out of non-living things. They can just magically appear. So Francesco Redi does this experiment by using rotting meat. See, now I said rotting meat, and some of you are intrigued, and some of you are a little disgusted, and that's okay. This is the same reaction your students are going to have, but they should be interested. So he was trying to disprove that rotting meat gave birth to flies. Again, this was a concept that people actually thought was true back then. So he sets up an experiment where he sets one piece of meat in a jar exposed to the air, and then another piece of meat in a jar exposed to the air, but this one had a cheesecloth that was covering the opening. So needless to say, after a few days, the open jar had maggots crawling out, but the one with cheesecloth, or the one that had the cheesecloth covering, did not. So this showed that maggots were indeed coming from flies. And again, I know this sounds gross, and it is, but one, this is a great step towards what would later become the cell theory. And 2, because it is gross, it's really going to keep the attention of your students. You can have them, again, just work together and go through the different steps of the scientific method and identifying when was he doing a controlled experiment, what was the independent variable, what was the dependent variable. So on this next slide, it actually is a way that I have found to be able to explain the independent and dependent variable for students. It's just one that no matter what the age group is, they tend to have a hard time distinguishing the difference between the 2. So if you have your students write a hypothesis as an if-then statement, then it will make it very easy for them to identify the independent and dependent variable. So for example, if I do this, then this will happen. If I do this, that is the independent variable. That is the one thing that you are manipulating. That is the one thing that you are actually in charge of changing. All right, so if I do this, then this will happen. Well, that's your results. That's your dependent variable. So again, if you write it as an if I do this, then this will happen. If you write as an if-then statement, then the independent and dependent variable should jump out. So what I did is I wrote down 3 simple hypotheses on here, and what I like for you to do is, you don't have to write anything down, but as you're listening, I want you to really think about, all right, what is the one thing that's being manipulated here? What is the one thing that I'm in charge of changing, or the independent variable? And what would be the results? What would be the dependent variable? So here we go. If I freeze tomato seeds for 2 days, then they will sprout faster than non-frozen seeds. So that's the first one. If I raise the angle of a ramp, then the cars will go further. That's your second. And then finally, if I change the color of the paper, then the students will be able to recall more words from memory than words written on paper. Okay? Think you got it? All right, let's try it out. Okay, so everything in red is the independent variable, and everything in green is the dependent variable. And again, you will get a copy of this PowerPoint so you can see it more clearly. But basically, for the first one, if I freeze tomato seeds, that's the independent variable. For the second one, raise the angle on the ramp, that's the independent variable. If I change the color of the paper, that's the independent variable. That's the one thing that you are actually changing, that you're manipulating. So for the dependent variable, again, the results, and a key thing about the dependent variable is that it must be measurable. It has to be something that you can measure. So for the first one, will sprout faster is your dependent variable. Will go further, your dependent variable. Recall more words would be your dependent variable. This is a really good lab that I found on your textbook, and this one's actually on page 37, not page 3. Sorry about that. It's page 37. And what they're trying to do is they're trying to see if the different floor surfaces make a difference in how high the ball will bounce, which is great. And this is a fantastic way to get students involved in the scientific method. Another thing you may want to try with this experiment, just a variation of it, is have students try different kinds of balls. They can do like bouncy balls or golf balls, tennis balls, same height, see if it makes a difference. You can try changing the temperature of the balls. So let's say that you have ping pong balls. Put one ping pong ball in room temperature water, put another one in ice water, and put another one in slightly warm water. You can just take the water and heat it up for like 45 seconds in a microwave and then put the ball in there for just a few minutes and see if the temperature makes a difference. And by the way, it does. All right, but this is a nice way for students to actually walk through the scientific method. So again, thank you very much for your time. I'll make sure that you receive a copy of this presentation. And as always, should you have any questions, feel free to send me an email or give me a call. Thanks so much.